11, section 11.2, properties of tangents. So we reviewed all this vocabulary yesterday. We talked about some old previous ones like circle, center, radius, diameter, and we also introduced some new vocabulary: tangent, secant, point of tangency, chord. And so today we're going to focus on a couple of properties of tangents and use those properties to solve for missing values or to determine if something is a tangent or not. And so remember from last time, a tangent line intersects the circle exactly one point, at exactly 1 point. Good grief. A tangent line intersects a circle at exactly 1 point, called the point of tangency. A tangent line, or a line, is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. All right, so if I have a line like this, and I'm going to cheat and move it so that it doesn't look like it's intersecting twice. So if I have a line like this, and I'm wondering, is this really a tangent, or has my eye deceived me and it's really maybe closer and hitting twice? The way I can tell is that if this is perpendicular, then if this is my point of tangency, okay, here's my tangent. Okay, here's my radius. If they are perpendicular, so form a right angle here, they have to be a tangent. And so the way we can check that is if I have a point out here, notice that I'm now creating a right triangle. And so last unit or last semester, we practiced lots of things with right triangles, as far as special right triangles, trigonometry. Mainly this unit, we're going to review some of those Pythagorean Theorem ideas that says, okay, if I need to check, whoop, look at me doing a quadratic there. If we need to check a tangent, we can do a squared plus b squared and make sure it's equal to c squared. If this is true, then we know we have a tangent. If it's false, then not a tangent. And so let's look at our first example. It says determine if AB here is a tangent to circle P. All right, so here's our tangent. There's where we think it's touching just once. And so we're trying to figure out, is this a right angle? So when we do a squared plus b squared equals c squared, C has to be the hypotenuse. And so that's going to be where we think it is across from the right angle. So here we have the length 8. There's our radius. The tangent we're trying to check here to see if this works is 15. And they're telling us this entire piece over here is 17. This is also our largest side. So when I check this, I'm going to do 8 squared plus 15 squared, and I'm going to check, is it really equal to 17 squared? So in my calculator, I'm going to pull up my calculator and I'm just going to check, is this really equal to 17 squared? Let me get this pulled up. All right. So on my calculator, I'm going to check, what is 8 squared plus 15 squared? All right, I get a value, 289. Okay, so 289, and then I'm going to check, what is 17 squared? Oh, 289. So because these two are equal, this is going to tell us that this is a true statement. And if I have a true statement, then yes, AB is a tangent. On number 2, if we look at it here, now we have, okay, here's my tangent. I don't know if this is really tangent or touching once or twice. So here's where I think the right angle should be. And then we have this piece. But notice that they didn't go all the way through to the center. They just told us that this piece out here is 5. So one of the things we have to do when we're trying to do a squared plus b squared equals c squared, I have an a, I have a b, but my c has to go all the way from the end to the center here. So what we need to do is we need to find this entire distance. And so they gave us the 5 here, but what about this length inside? This is where we're going to use the property of circles that says every radius inside, no matter where I draw it to, from here to here to here, all of them are 11. So if I know that this piece is 11, so is this interior piece here. That's another radius, making the entire length 16. So now I can check, is 14 squared plus 11 squared equal to 16 squared? So I can check that on my calculator. All right, so I'm not solving for anything, I'm just checking. Is this a tangent? So here I'm going to get 317 and check 16 squared. I get 256. Okay, so those two are not equal, so this is a false statement, meaning no, AB is not a tangent. And so this is how we can check to see if we have a tangent. On the next ones, it's going to say, given a tangent, can we find x? Round to the nearest tenth here. All right, so when we're looking at this, now we're saying, okay, JK is tangent. JK, that means there's my right angle. JK, there's my right angle. JK, here's my tangent, there's my right angle. So I'm still going to be using a squared plus b squared equals c squared. But now I'm not going to have all the pieces. I'm not verifying true or false. I'm finding one of the missing parts here. So here, okay, always points across at C. So I'm looking for 7 squared plus 19 squared equals to x squared. A, the radius, B, the tangent, C, all the way across from outside point to the center. All right, so grab our calculator and we can check what is 7 squared plus 19 squared. So we get 410 equals x squared, and we've just spent several units looking at solving quadratics like this. Square root, square root. There are 2 answers here. We're going to ignore the negative one because we're looking for a distance, and distances can't be negative. So we're back in kind of the geometry world, not the algebra world. So if I take the square root of 410, let's see what we get. Square root 410. Okay, it just tells me square root of 410, but since it tells me to round to the nearest tenth, I'm going to use my toggle button, and I get 20.2. All right, so it tells me, okay, that's just radical 410. Rounded to the nearest tenth, I get 20.2 as my answer, rounded. All right, so visually, it should be longer than 19, so that makes sense there. So we have some confirmation visually as well. All right, on number 2, I have radius. Here's A, B, and then look at this. It's not giving us that entire distance. So just like we did up here, where we had to use the radius, 11, it happens that this radius is also 11. So that the whole distance here is 11 plus 7, or 18. So I can set up x squared plus 11 squared equals 18 squared. If I tried to do 7 squared, I'll get a negative. And I know this length exists, so it can't be a negative there. All right, so now that x squared is one of my parts, a squared here, I need to subtract over the 11 squared to get x squared by itself. So I'm going to take 18 squared and subtract over the 11 squared, leaving me with x squared equals 203. Square root both sides. Okay, and we're left with square root of 203. Let's see if that simplifies. Square root of 203. All right, we want an approximation, so I'll toggle, and I get 14.2. So we're leaving this in decimals, mostly because if we're talking about measurements, we typically would round. I wouldn't say, okay, I am about radical 203 inches tall. Well, if one, I'm more than 14 inches tall. But it's that idea that we wouldn't, an approximation would be better here than the exact. All right, on number 3, now we're looking at, okay, I have my tangent here. I have the whole length here, but now I'm missing this piece. Again, so it's 11 again. They're not always 11, but if this was 12, this would be 12. If this was 32, this would be 32. It's the fact that this is a radius and so is this other side, making this entire piece 11 plus 11, making that 22. So I can check now x squared plus 22 squared and see what I can make that x to make it equal to 25 squared. So on my calculator, I'm going to take the 25 squared and subtract over the 22 squared to get x squared by itself. And then I'm going to square root. All right, undo our squaring. Just doing our inverse operations here. All right, and let's see what our approximation is. So square root of 141, square root of 141, approximately 11 point, ooh, that 7's going to bump it up, 11.9. And that would be my measurement there. So the first tangent property says that if it's going to be a tangent, we need this right angle. So we're using Pythagorean theorem to either check to see if it's a tangent, or if we know it's a tangent, that property applies, and we can find missing pieces. We have 2 more rules here. The next tangent rule says that if 2 segments from the same external point are tangent to the same circle, then they are congruent. All right, so here's our exterior point. It's outside of the circle. Here's a point of tangency for this tangent. Here's a point of tangency for this tangent. I know it's tangent because of that right angle. If they're on the same circle D here, then this piece has to be the same as this piece. So set equal. Kind of a follow-up here, it says if a polygon is circumscribed around a circle, then all the sides are tangent. So if I put inside here, I guess outside, if the circle is inside of a triangle, then every one of these pieces is a tangent. And so now we have exterior point B, exterior point C, exterior point A. But it's still going to say, just like those 2 pieces will match, these 2 pieces will match, and these 2 pieces are matching. So we end up with 3 different matches here, where we would get a piece that's going to match A to D matches A to F. And then we would get D to B matches B to E there. And we get this last match over here. And so it kind of reminds me of like a ice cream cone, where I wanted to support that ice cream, and so those 2 pieces have to be the same, no matter where I draw it. So let's look at these problems. All right, so now we don't have a radius drawn in. We're looking at the segments that have 2 tangents here. And again, find the value of the measure and assume that segments that appear tangent are actually tangent. So if these are 2 tangents to the same exterior point, these have to be the same measurement. Exterior point, tangent, tangent. Exterior point, tangent, tangent. Exterior point, tangent, tangent. We can now set these up by setting them equal. Congruent parts give us equal measures. So 5x plus 23 has to equal the other side, 8x minus 19. And now we can solve for x. So I'm going to subtract 5x over. So 8 minus 5 is 3x. I'm going to add 19 over. 3x comes down, and I'm left with 42. And divide by 3. X equals, I can't do that one in my head. 42 divided by 3, I get 14. All right, so it asked us to find x. We found x. On the next one, equal Congruent parts give us equal measures. So 14x minus 13 equals 8x plus 5. Subtract 8x. Add 13. I can do this one in my head because I divide by 6 and get 3. All right, so on this one it said find x and we were done. This one says take it one step further and tell me what is the length of P to Q. So I need to plug this in. 14 times 3 minus 13. When I plug this in, now I get, what do I get? Let's see. 14 times 3 minus 13. I get a length of 29. So it wanted us to not only find x, but then find the length of this. This is 29, which means so should this one. And I could even check that if I wanted to make sure I have that correct. 8 times 3 plus 5 should be the same as the other side, and it is. Those two match, so I know that I have my correct answer. On number 3, okay, we have x plus 12 has to equal 4x plus 9. Subtract one of the x's over, leaving me with 3x. Subtract the 9, leaving me with 3. And 3 times 1 is what x will have to be. Find x. Now we're done. On number 4, 2x plus 3 has to equal 25. Two tangents, same exterior point. Subtract 3. 25 minus 3 is 22. Divide by 2. X equals 11. Ooh, I almost circled my answer, but this is not what it wanted me to find. We needed to go one step further. It's asking us to find our S. All right, so I need to plug in 2 times 11 plus 3. 22 plus 3, 25. You guys, I just realized it said find R to S. If I already knew T to S was 25, could I go directly to this? Absolutely. Do we find the X and confirm it? Sure. But I already knew what R to S was even without knowing X here. I didn't actually need it. So I got excited about solving for X and then didn't really need it on that one. All right. This one now we have 3 tangents. So again, I'm going to go through and I'm going to say, okay, here's an exterior point. This piece is the same as this piece. Here's a different exterior point. This piece is equal to this piece. Here's a third exterior point. This piece is equal to this piece. And so as we're looking at this, we want to make sure that we are applying the rules that they're giving us. It says A to C, okay, so I'm going to write A to C is 18. Okay, well, I have blue and pink. These are not the same, so I can't just divide this in half, but at least I've labeled this piece. And then it says C to E is 30. Okay, well, wow, these are not the same piece. D to E is much larger. C to D is much smaller, so this is not just divide by 2. And then the last piece they tell us is A to F is 10. Okay, well that now is one of the parts. It's not the same as the green, but I do know it's the same as the pink. Those two have to match. There's my ice cream cone. Now can we work around to find F to E? All right, so that's our goal here. I already did the match here that said, hey, these two are pink, they match because these are tangents from the same exterior point. Now that I see that, I can go around the world here. These two have to add up to 18, so they're close to the same, but 10 plus 10 would be 20. I need 18 minus 10. I need 8 here. Blue matches blue. There's an 8 as well over here. There's my ice cream cone. And 30 minus 8 gets me 22 over here. Green matches green, and I've gone all the way around the world. Here's what I was looking for. F to E. So again, I used what was given. We were given this piece, we were given this piece, and given this piece. And so what I did was I took the idea that said, okay, these two have to match because they're a tangent to the same A out here. These two had to match because they're the same exterior point C. These two also have to match. So that's where I called it around the world to get back over here. I can't go this way because I don't know what these two add up to. All right, on number 6. Okay, so again, as soon as I see those tangents, I'm going to highlight I have 2 pieces, same exterior point. I don't know why it's a little lopsided there. Let's take 2. And I have another exterior point. There's my next one. And the last one over here. So again, on these sides, pink matches pink, yellow matches yellow, green matches green. So they do tell us that the perimeter is equal to 40. Okay, so that means I know all of these add up to 40. A to C, okay, they're giving us this entire piece, is 15. A to F is 8.5. Okay, pink to pink, here's 8.5 as well. And our goal is to find F to E. Sorry, I get a little excited sometimes when I'm like, okay, I used this piece, I have this piece, and we still have to figure out how we're going to use that. All right, so I do have a match here, but I can't find FE because I don't know what this total is, and they're different. One's pink, one's green. All right, so these are different, but they have to add up to 15. I need to practice in my head. What is this subtraction? 6.5. All right, so since I knew they had to add up to 15, I can subtract to find what this missing piece is. Yellow matches yellow, so this will be 6.5. And then I kind of get stuck. So I want to go all the way around. I need to somehow get back to this one. That's where F to E is. So we have used everything but this perimeter. So if I took away and I said, okay, the whole perimeter is 40, and I already know I have used 8.5 of it, and I've used another entire 15 of it, and then this piece over here, 6.5. I have 10 left over for both of these pieces. So if I have 10 for both of these green pieces, each one of these, I can divide and find that F to E has to be 5. These two pieces have to match, so it can't be 2 and 8 or 1 and 9. They have to be the same, so I can divide by 2 to find that piece. And again, I can check my answer a couple of different ways. I could say, okay, let's walk around this, make sure it adds up to 40. So 5 plus 8.5 plus 8.5 plus 6.5. I'm just walking around here. 6.5 and 5 takes me all the way back. 5 plus 8.5 plus 8.5 plus 6.5 should add up to 40. That I know I've done correctly. So we had 3 tangent rules today. Tangent rule number 1 says that they're perpendicular to each other, forming that right angle. Pythagorean Theorem helps us on those. And the second and third are related. That says if I have an exterior point, the tangents are the same. So we can set them equal or use them like this to get some matches going on. Let me know if you have any questions.